into inscribed angles today. It's an angle with a vertex on a circle and sides that contain chords. Okay, and then we'll take a look at an example. There's three types of ways we could write an inscribed angle. The first case is one of the chords, one of the sides on our angle could go right through the center. Okay, and my inscribed angle would be this guy right here because it has a vertex that is on the circle. And we have a theorem with this that's going to help us find what that angle measure is. Well, we can also have an inscribed angle when the center is inside of the inscribed angle. And it could be where the center is outside of the inscribed angle. But as long as the vertex touches the circle, just like it is in all three cases, and it has sides that are chords, so basically going from the vertex to another side of the circle, another point on that circle, it would be an inscribed angle because it's drawn kind of inside the circle. And our one theorem with this is that if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So let's think about this here. So this measure, the measure of angle 1, measure of angle 1, that's going to equal, it says half of the arc, the intercepted arc. Well, what arc is it intercepting? Let's take a look at our sides. It's going to here and it's going to here. So it's intercepting this arc right here from A, oh, bad drawing, to B, from A to B. So there's my arc, AB. So I'm looking at that arc AB. So it's half of AB. So for example, let's just pretend measure of AB is 80 degrees. So this is 80 degrees. Well, what would that make the measure of angle 1? Pretty easy. Cut it in half. So the measure of angle 1 would be 40 degrees. So remember, whenever, or a couple sections ago, we had central angles. So for example, if I had, boom, right here to this central angle, this would also be 80. Remember, those are the exact same. But now if it's intercepted, if it goes all the way to a different side on the circle, like it is right here, then it's half of that. Okay, so we have theorems to figure out some of our angles that can be drawn inside our circle now. Central angles are the same. Inscribed angles are half of the arc. So let's use that information. Let's go ahead and solve for measure of angle x. Well, if I'm looking for the measure of angle x, it's inscribed, right, because it's right on the side of the circle. So it's half of the intercepted arc, so just half of 86. Well, half of 86 would be 43. So I know that measure of angle x is 43 degrees. Well, let's take a look. I'm trying to find the measure of arc at yx now. So I'm trying to find the measure of arc yx. So I know that its inscribed angle is 52. And if it's inscribed, that means the arc is twice that, right? So this would be 104 degrees. Because the inscribed is half of the arc. So 104. So pretty straightforward, right? The arc is just double the length, or double the angle measure of the inscribed angle. And vice versa. Okay, we have another theorem here. Let's just draw myself an arc. Let's say I had arc AB, for example. And let's say I draw an inscribed angle, let's say about like right here. Okay? And let's just call this angle angle 1. And let's draw another inscribed angle, but I'm going to have this guy touch right here. And we'll call this angle angle 2. What do you think you could say about measure of angle 1 and measure of angle 2? Obviously, I don't know their value. I don't know if they're like 40 or 50 or anything like that. But what, can I state anything about them? What do you think? Well, if you notice, they both intercept arc AB. So won't they both be half the arc measure of AB? So for example, if AB was 50 degrees, wouldn't these both be 25 degrees? Because they're inscribed angles off of that arc. So we could say that they're equal. So basically, if I have inscribed angles that intercept the same arc, then they are equal, are congruent. So let's use that information here. Sometimes it takes a little bit to look closely to figure out what you're trying to do. So for example, here I'm trying to find measure of angle R. So don't forget that they're actually finding an angle measure, not just X. But if I look, I'm given information about these two angles. So what I usually do when I'm given that, I try to find out, well, those angles, let me see if I know anything about the arcs that they intercept. So if I look here, here's this angle, and here's the other angle. And if you notice, they intercept the same arc. So what can I do with these two expressions here? If they intercept the same arc, we know that they have to be equal. So I could set 9x plus 2 equal to 12x minus 13. And then just go through our algebra and solve. So I'm going to get my x to one side, so I'm going to subtract 9x from both sides. And then I'm going to add my 13 to the other side. So we're left with 15 equals 3x. And divide by 3. So x equals 5. And it says I want to find the measure of angle R. So I got to go plug this back in. I got to plug 5 in for x up into this expression to find angle R. So we got to take 12 times 5. So measure of angle R. 12 times 5 minus 13. And 12 times 5 is 60 minus 13, and we end up with 47 degrees. So that means I also know that angle S would also be 47 degrees as well. And if I really wanted to find the arc, I could. It's just twice that. So that would be 94 degrees. Okay, so all kinds of things you can do with our intercepted, our inscribed angles here, the ones that intercept arcs. Well, what happens if our inscribed angle intercepts a diameter? Like in this case over here. I have an inscribed angle and it intercepts a diameter. Well, how many degrees is the diameter? 180. So from F to H, it's 180. It's a semicircle, right? So that means I know that the inscribed angle is half of that. So that's got to be 90 degrees. And that's what this is stating here. So if you have a semicircle or we intercept a diameter, then the inscribed angle is half of that, which has to be 90 degrees, so we get a right angle. So anytime you have an inscribed angle on a diameter, it's 90 degrees. Oh, I got one more. Let's use that. Let's use that information here. So if I notice, here's my diameter, and I have an inscribed angle right there. So what do I know? Well, this arc is 180 right here. And so the inscribed angle has to be half that. And we just had that theorem, so I know this is a right angle. I know this is 90 degrees. Well, I got a couple expressions here. So basically I know that all three of these angles, this guy, and my 90 degrees, add up to 180. So that's one expression I could set up. Or if I notice, if this guy's 90 right here, that means these other two have to add up to 90, right? Because 90 plus 90 gives me 180. So that's what I'm going to do. I'm going to set x plus 4 plus 8x minus 4 equals 90. I also could say plus 90 equals 180, but either way is just fine. I know that these two have to add up to 90 since this guy was 90. And then it's just our algebra. So x plus 8x is 9x. 4 minus 4 is 0, so I can just get rid of that. Equals 90, so these two canceled. And divide by 9. So x equals 10. And what did it ask for? Angle B. And where is angle B at? Right down here. So I'm using this guy. So to find the measure of angle B, I got to take 8 times, well, we just said x is 10. So 8 times 10 minus 4. So 80 minus 4. And 80 minus 4 is 76 degrees. There we go. So that means measure of angle A must be 14. And my last theorem is if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So that means angle L plus angle N would add up to 180. They're supplementary, that's what that means. So measure of angle L plus the measure of angle N would add up to 180. And that should make sense, because if I think about it, L is intercepting that arc right here, and N is intercepting this arc right here, and those total 360, and half of that would be 180. So it kind of makes sense, right? So that also means K and M, so measure of angle K plus the measure of angle M is also 180. So opposite angles on inscribed quadrilaterals are supplementary. So let's use that to solve this last problem. It says find the measure of angle S and the measure of angle T. Well, we just said opposite, we got a quadrilateral, right? That's inscribed on this circle. So we know that opposite angles are supplementary. So if this guy is 90, its opposite angle is right over here. Well, 90 plus what gives me 180? 90 plus 90. That one's pretty easy. I don't really need to do anything with that. So measure of angle S is 90 degrees. Just remember, opposite angles aren't congruent. They add up to 180. And then lastly, we got 14x and 8x plus 4. They're opposite angles, so they add up to 180. So I can take 14x plus 8x plus 4 equals 180. So I add my x's. I got 22x plus 4 equals 180. Subtract our 4 from both sides. So 22x equals 176, and we divide by 22, and x is going to give us 8. And what does it say? Find the measure of t. So I got to plug this guy back in to find the measure of t, so don't forget to do that. Always read your directions. So it looks like we got 8 times 8 plus 4, that's an ugly 8. So 64 plus 4, which is 68 degrees. And there you go, just using that, our little theorem that we came up with there. Okay, there's your assignment.